Hello everyone, welcome to this session on Python file handling and exception handling. So in today's lecture we will cover important concepts relating to handling files and managing errors in Python. The session is divided into four main parts. Number 1 file basics, number 2 directories, number 3 exceptions, number 4 practice. Let's understand each section one by one. File basics. Okay, so the first topic is file basics. In this section, we will learn how Python works with files. We will cover opening files, reading files, writing files, closing files, different file modes, file handling workflow. Files are used to store information so that data can be accessed whenever required. In Python, we can perform different operations on files such as creating a file, reading information from a file, writing information into a file, adding new information, managing files safely. The important operations are open, read, write, close. This is the basic overflow used while working with files. So the second topic is directories. A directory is basically a folder that contains files. Python provides modules to work with the directories. In this section, we will learn about OS module, creating directories, listing files, checking paths, managing file paths. So now talking about exceptions, the third topic is exceptions. While running programs, errors can occur. For example, dividing a number by 0, opening a file that doesn't exist, converting invalid data types. Python provides exception handling mechanisms to handle these situations properly. We will learn try, except, else, finally. These blocks help us write programs that can handle errors safely. So the final section contains practice exercises. We will implement error handling in a calculator, safe file reading, creating exception handling programs, logging errors. These exercises will help us apply the concepts practically. So this is the overall agenda of today's session. So if you want to write these things in your notebook, so you can write this. Now let's start with the first practical concept, opening files. Whenever we want to work with a file in Python, the first step is opening that file. Python provides the open function for this purpose. The basic syntax is, just you can see the example here. Okay, the mode tells Python what operation we want to perform on the file. The primary file modes are R, W, A, X. These are also binary modes RB, WB. So let's understand each mode. So this is mode is used for reading files. When we open a file using read mode, Python allows us to access the contents of that file. For example, you can see here the example. Here Python opens data.txt for reading. The next mode is W. This mode is used for writing data into files. Important point, W mode truncates the file. This means if the file already contains data, that existing data will be removed and replaced with new data. So for example, if we write W in place of R, so we should use this mode carefully, okay? Okay, so append mode is A. This mode is used when we want to append new data at the end of an existing file. Unlike write mode, append does not remove previous content. So the create mode is X. This mode creates a new file. If the file already exists, it will give an error. Okay, so talking about binary mode, RB and WB, these modes are used when working with binary data. So closing files and context managers. After working with files, we should always close them. Python allows us to close files manually, but a better approach is using context managers. Here Python automatically closes the file after completing the operation. This helps avoid resources leaks. Now let's move writing data into files. Python provides methods to store output into files. The two commonly used methods are write and write lines. Using write, the write method is used to write a string into a file. For example, here you can see the example. Let's understand this code. First, with open output.text comma w as files. So it opens the file in write mode. If the file does not exist, Python creates it. Then file.write hello world slash an writes the text into the file. The slash an represents a new line. Okay, so using write lines, the write lines method is used to write multiple lines into a file. It accepts a sequence of strings. Important point about write mode. Remember, W mode overwrites existing data. For example, if a file already contains information and if we open it using openfile.text.w, the previous content will be removed. If we want to add data without deleting existing information, we should use A, append mode. So if you want to write this in your notebook, please write. Now we will move to the next topic. Okay, just wait. Okay, so reading structured data. In real world applications, data is usually stored in a structured format. For example, a student records may contain student name, roll number, score. A file may store informations like Rahul 101, 85, Amit, 102, 90. Each value is separated by a comma. To process this data, we need to read each line as separates the line. So reading data line by line, when working with large file, it is better to process data line by line instead of loading the complete file into memory. So here you can see the example. Here the file is opened in read mode. The for loop reads one line at a time. Each line is processed separately. This approach is useful when files contain a large amount of data. So splitting data. So if name is equal to Rahul, if we need to separate name is equal to Rahul, roll number is equal to 101, score is equal to 85. For this we use split parenthesis, then quotation mark, simple quotation mark and comma. Okay. So, student record, just wait. Okay, so now we will learn about directories. A directory is a folder that stores files. Python provides modules to work with directories and paths. The commonly used modules are OS pathlib. These modules allow us to perform file system operations. OS module. So this OS module provides functions for interacting with the operating system. Some common functions are os.mkdir, os.makidirs. So here you can see the common functions. Let's understand these functions. Okay, so this function os dot, where is the cursor? Okay, so this function is used to create our dictionary. Okay, and also this creates a okay, so this is that. And the function os dot make dirs, it can create, it is used to create multiple directories. It can create nested folders. Okay, the function os.list directory, it is used to display files and folders inside a directory, and it represents the current directory. The output will show the files and folders present there. os.path exists. Okay, so this function checks whether a file or directory exists. It returns true if exists, false if it doesn't exist. This helps prevent errors before accessing files. So this function, this creates a correct path according to the operating system. It works across different platforms. So if you want to note down these things in your notebook, so you can. Now we will start the next major topic, exception handling. While executing a program, errors can occur. These errors can stop the program unexpectedly. Python provides exception handling to manage these problems. There are two main types of errors. Number one, syntax errors. Number two, runtimes error. So talking about syntax error occurs when the code structure is incorrect. These errors happen before the program starts running. For example, missing code, colon, okay. So it gives a syntax error. Okay, runtime errors. Runtime errors occur when while the program is running. Examples: dividing by zero, opening a missing file, invalid conversion. So this code is exceptional handling allow us to handle these situations properly instead of allowing the program to crash. The main keyword used are try, except, else, finally. We will discuss this in the next section. Okay. Now we will discuss some common exceptions that occur while executing Python programs. Exceptions are errors that happen during program execution. Python provides different exception classes for different types of problems. The important exceptions covered in this section are: number 1, zero division error, value error, type error, file not found error. Let's understand each one. Number one, zero division error. The first exception is: this error occurs when we try to divide a number by zero. Okay, because division by zero is not mathematically possible. To handle this error, we can use exception handling. The second exception is value error. This error occurs when we provide an invalid value for an operation. Okay, for example, int abc. Here Python tries to convert the string into an integer, but this conversion is not possible. So Python raises value error. The value exists, but it is not suitable for the required operation. So talking about type error, the third exception is type error. This occurs when we perform an operation on incompatible data types. Here 2 is a string, 3 is an integer. Python cannot add these two different types directly. Therefore, it generates type error. To solve this, we need to convert the values into compatible types. Number 4, file not found error. This occurs when we try to open a file that doesn't exist. Okay, for example, if the file is not available, Python raises file not found error. This exception is very common while working with files. We can handle it using try and except blocks. So handling specific exceptions. Each exception has its own class. This allows us to catch specific errors and provide suitable solutions. For example, handles division error differently, handle missing files differently, handle invalid input differently. This makes programs safer and more user friendly. Okay, so now we will learn the main structure used for exception handling in Python. Python provides four important blocks. Number 1, try. Number 2, except. Number 3, else. Number 4, finally. These blocks help us control what happens when an error occurs. So try block. So talking about try block, the try block contains the block that code that may produce an exception. Okay, so for example, x is equal to 10 divided by 10. Python 0, sorry. Python will first execute the code inside the 0 block. If no error occurs, the program continues normally. If an error occurs, Python moves to the except block. So the except block handles the error. Instead of stopping the program, we display a proper message. Okay, so the else block runs only when no exception occurs. Talking about the the finally block always executes. It runs whether an exception occurs or not. This block is generally used for cleanup operations, for example, closing files, releasing resources. So why exception handling is important? Exception handling helps us prevent sudden program termination, display meaningful error messages, handle unexpected situations, create reliable programs. For example, in file handling, instead of the program crashing while when a file is missing, we can show file not found. Please check the file name. So write down in your copy this notes. So we will practice this concept through lab exercises. The purpose of these exercises is to apply file operations, exception handling, safe error management, where we solve three practice questions. So number one, handle calculator errors. Build a simple calculator that uses try except to manage zero division error and value error. So the first task is build a simple calculator that use try or except to manage zero division error and value error. In a calculator program, users provide inputs. While taking inputs, two common errors can happen. Number one, user enters invalid values. User tries to divide by zero. Okay, so you have to do it by yourself. Okay, and first do this question, then we'll talk about the second question. So practice question number two, read missing file safely. The second task is attempt to open a file if missing, create it and write sample headers. While working with the file, one common problem is that the required file may not exist. Okay, instead of allowing the program to stop, we can handle this situation. The approach is try open the file. If the file exists, continue reading. If the file is missing, create the file, write required headers. This allows the program to recover from the error. So this question also you have to do by your own. So do this question. So the third task is read students' codes, skip malformed lines, and log errors to error log. In real-world files, sometimes data may not be in the correct format. For example, a student record may be incomplete or incorrectly written. Okay, so here you can see, just wait, no, that's not. Okay, so you have to do this question by yourself. I know you guys can do. Okay, so thank you.